In resolution of several concurrent forces, you have the question either already in the geometric form or they are in word problem. Now I want to talk about what you need to know now. If it's in geometric form, then you need to do something. Like the word problem, every direction is given as an inclination from the positive x-axis. So if I should draw this diagram, I am going to write all this angle as inclined from positive x-axis. Let me show you what I mean. So for question 9, these are the inclinations. The first force is 310 Newton in the direction 45 from the positive x-axis. This is the positive x-axis. The inclination angle is 45 degrees. The next force is 280 Newton in the direction 135. So from the positive x-axis 135, this is the force 280. The angle of inclination is 135. The last force is 400 Newton and the inclination is 80 degrees. This is the force, 80 degrees. So this is the geometry of this question. So every question given to you in word problem, if you want to interpret it geometrically, all the inclination has to be from the positive x-axis. But if the question is drawn already, then you have to reinterpret all the inclination with the positive x-axis as the angle of inclination, because that is where the formula was derived from. This is how we got the formula. The inclination is from the positive x-axis. So to get, this is a force in this direction. So to get the horizontal component force, that is F subscript x, you use this trigonometric ratio. If you relate it with the force here, this is the hypotenuse, this is the adjacent. So adjacent over hypotenuse is cos. So if you have f of x over f, that will give you the cos theta. So this is the horizontal force we are talking about. So to get the horizontal force, you have the force cos angle of inclination. So this is the formula to get the horizontal force component. So the vertical component here is the hypotenuse, opposite. Opposite over hypotenuse is sine. So your f of y over f is sine theta. That makes your vertical component f sine theta. Now this is your vertical component force. This is your horizontal component force. So you can see we got these two formulas from the inclination from the positive x-axis. So if you must use this formula, you must incline all the angles given to you as positive x-axis. Otherwise, you can as well solve it by deriving your own formula. If you incline this with the negative y-axis, you derive it, use your trig ratio, you will still get the answer. But for convenience and just stick with the formula, it is best you just resolve every angle here to the positive x-axis. Now in solving this question, you see that it's convenient by resolving everything to the positive x-axis. Let's see the solution. In finding the magnitude of resultant forces, when you have several forces, you have to resolve them into their horizontal component and their vertical component. So when you do that, this formula, what it means, this one is representing the resultant force, so this is the magnitude. It's equal to the square root of the sum of all the horizontal forces, square it, plus the sum of all the vertical forces, square it. So this formula is to find the magnitude of resultant forces. So direction of the resultant force is the sum of the vertical force over sum of the horizontal force. In other words, alpha is the direction angle. That is the tan inverse or arctan of the sum of the vertical force over the sum of the horizontal force. Now, magnitude of resultant force, not forces. Now, because the resultant is the result of all the forces, so the magnitude of the resultant force, it has now become one force. So this is it. So let's go down to the solution to those questions.